Good afternoon. So today we shall be looking at regression analysis in R. We shall basically focus on how to import data from a Stata file to R, and also how to do linear regression, and also how to do some multiple linear regression. So to begin with, when you want to do linear regression in R, of course, it's always better to first look some packages. And most of our packages, like maybe this library mass will be basically used for or makes it able when you want to run the multiple regression. Also, maybe this XL, which should be being asked to import an Excel file. And also, in this case here, since we shall be dealing with a Stata file, it is best when we import or when you run a library code, right? Library heaven. So library heaven is basically what will help us basically to import our Stata file, and also the library HIMIC will help us in forming data quotient for maybe the factors, the factor loadings, the variables, and also maybe the deep prior, which will be helping us in doing some data manipulation. So to do all this, it's also first better to begin with setting working directed. So we shall come, we go to session, then we go to setting working directed, then we go to choose. So when you do this in most cases, it is always to help us to look for a product which contains our data set. So in this case, it was in this product, there are three semester one, let's go computing, and that's for notes. So this is my working directed. And so that has been set. So I think that's this. Set working directed, then they're giving us the file path. And this is a folder in which our data set is contained. So then if we are to proceed, so maybe we can also copy maybe this command, then we paste it here. Then we shall of course add a comments. And when you're adding a comment in R, you begin by hashtag. So we shall be like setting a working directory. So that's what I'm saying, working directory. And now, since this data, which is an Stata extension, so we want to rename it and call it and give it an object called live. So we shall read DTA. This is a command which is embedded in the library heaven, which previously did what? Called. So we just of course do this control enter. So we have imported our data set live data, and I've been done with what? Live, and it has 68 observations and 6 variables. So we're also going to look at maybe how it looks like. Just click on either view, just say view, and V is supposed to be a calculator. View, open brackets, live. So here, this helps us to know which variables we shall be dealing with. So you can see we have the region, we have the country, we have the population growth, we have the life expectancy, we have the GDP per capita, etc. So this will be our data, which will help us to perform linear regression, multiple linear regression. So we come back to our script. So now, of course, when we want to run linear regression, of course, we need to have a dependent variable and an independent what? An independent variable. So in this case, we are trying to look at maybe factors that determine or predict what? The population growth. Also, in our data set, we have the population growth, which is 1.2. So it's like the average rate or the annual population growth. So one look at factors that determine what? The population growth. So to do this, of course, we need to assign our model. We need to assign our results, like something which is given like any name, it can be a model. So we shall be running a linear regression, so it is RM. And of course, we are running a population growth against what? Life expectancy. So why we do this in terms of the life is that the life is our data set, and we are picking a variable what? Population growth, then we are running it. And this to get this command, it's always below the escape button in your laptop. So when you run such a model, first gives us a model and creates some new data set or new observations in our environment. And if you want to look at the results, you just have to to print the results of the model. So when you say Control Enter, you find that we are able to to print the results of our model. So if you are to proceed, you can see, of course, we have a linear model, which is the population growth against what? Life expectancy. And you can see that we have our y is equal to alpha plus beta, where we have 7.19 as our alpha and -0.0861 as our beta. So this is what? Our model. So we can let's say maybe a unit increase in life expectancy reduces the population growth by what? 0.8. Then, of course, there'll be some other formula to use. You can also look at maybe the model performance here. This one does not work, and it's not right. So there will be another way in which you can run your what? The linear regression. So in this case, you only need to know the data set. So give it another name, maybe like model. Model 1 is equal to, of course, to be a linear model. So we have been running about population growth against life expectancy, but it is coming from what? Data file. So this is also like another technique of running simple linear what? Regression. So as you can see, the same, and if you print the same model, you have the same what? The same results as we had previously. Where we have the alpha 7.1956 and our beta as negative 0.0861. Then of course the list here. So I think these ones are the same. So now this has been the basic what? A simple linear regression model where we run basically one dependent variable and one independent variable. So in some instances, we might want to run maybe a multiple linear regression model. So basically, the multiple regression model is where we have one dependent variable which is run against what? Multiple independent variables. So the easiest way to do this, of course, is like maybe give the object model 2. So it will be a linear model of population growth against all the other variables. So as you can see, you can keep on adding a list of very many variables after this sign. So this shows that is our model is the negation model of population growth against life expectancy and having safe order, and it's come from a data set called life. So this will be an example of what? Of a linear model. So if we want to see the results, as you can see, it does come here. Once see the results, we just print what? Print the results of the model. So we know we are here on the results of the model. So this is the results of the model. So you can see that, of course, when we added the variable safe water, change the what? Our intercept, and this is the y is equal to maybe 7.88 plus no minus 0.08279. That is beta and c minus 0.001127. Safe water. So in case maybe you would like to add some other variable, you can just repeat. Maybe it's model now 3 is equal to a linear model. So population growth. So we want to put the population growth. Population growth. Then we put this change. This shift. Shift this contain. So we are going to get a life expectancy we are also adding maybe save water. Then we also want to add some other variable. Another variable maybe what? GDP per capita. So by this one will be there to read. Let's add region. So plus maybe the what? The region. But from which data? From which data? Of life. So this will give us what? A multiple regression model. Now with now 3 independent variables. So if you try to control enter, you can see it is here model 3. And if you want to see the results, say print, then print model 3. So if you run this, you get the what? Our model with which has the what? 3 independent variables. Thanks for watching.